All right, so today we're starting the new lesson on composite shapes for area and perimeter. Next class, we're going to be working on some geometry as well for 3D objects. And then we're going to be talking about optimizing shapes. Now, right now, today and tomorrow's lesson, this is a review of things that you have done already. So I don't expect it to be too tricky, though I will throw in a few twists to make it somewhat interesting still. Okay, before we get started with geometry, we're going to talk a bit about measurement. We talk about measurement because we might be measuring things in various units. And so it's important that we are able to convert things from one unit to another. Now, in Canada, we generally use the metric system, although in Canada, we're pretty messed up in terms of what system we use. Because if you go to the grocery store, in the flyers, they'll all tell you the price per pound, but when you get your receipt, you will always see the price per kilogram. And the whole conversion thing is just not quite there. On the other hand, when you talk about the weight of yourself, often people say their weight in pounds, but if you're talking about the weight of a thing, it is in kilograms. So Canada is kind of funny that way. We're unsure of what unit to use. And so we use a bit of both. Okay, these are all the prefixes for the metric system. And one of the things that is excellent about the metric system is that everything is based on a suffix and it's based on the number 10. I'm going to give you an acronym here. King Henry died, unfortunately, drinking chocolate milk. Now, this silly acronym is out there because each one of these letters represent the beginning letter of the prefixes. So we have K for king, that's for kilo. Then we have hecto, deca. We have the main unit. Then we have deci, centi, and milli. So these are all part of the metric system, but it's not some of them we use very infrequently, such as deca or hecto or deci. We do hear a lot about kilos, as in kilograms, kilometers, or we hear centimeters, we hear about millimeters. And what do we have? Okay, so when we're getting smaller, so from a larger unit to a smaller unit, we always multiply by 10. Or you could say we are moving our decimal spot to the right that many units. So this is for getting bigger. So for example, if I'm starting out at kilometer and I'm going to centimeters, I need to count the number of steps it takes me to go from kilometer to centimeter. So I take 1, 2, 3, 4, 5. 5 steps. So I'm going to take 13 and I'm going to multiply 5 or sorry, 10 5 times. But doing that is a bit cumbersome. So we could just consider us moving the decimal spot to the right 5 times. So right now, this is 13.0000 kilometers. Now, it doesn't matter how many zeros I have after the decimal, it's still exactly the same number. I'm going to take this decimal spot and move it 5 steps to the right. So 1, 2, 3, 4, 5. That gives me 1,300,000 centimeters. Now, on the other hand, if we are going from a unit that is smaller into something that's larger, we're going to do the opposite. So we need to divide by 10 for each step, or you move the decimal to the left. Right, so in this example, we have what is 50,000 milliliters in liters. So if we're starting in milliliters here, and we're going up to liters, the word liters doesn't have a prefix. So because it doesn't have a prefix, we're actually speaking about our unit. So from milli to the main unit, I'm taking 1, 2, 3 steps. So my decimal is here. I'm going to move my decimal to the left by 3 units. So 1, 2, 3. So this is equivalent to 50 liters. Now, one more thing. If we're talking about our unit, this would be something like meters. We could have liters. We could have bytes if we're talking about computers. We could have hertz. What other ones? I'll just say etc. All right, let's go to the next slide. If we're going from imperial to imperial, we would have to use a ratio. So unfortunately, the imperial system is not base 10. And so we can't just move the decimal spot to the left and to the right. We're going to create a ratio instead. And when we create a ratio, it's like we have what I call a magic square. So we have our original and we have our new units. Then we would have, or sorry, let me rewrite that. So sorry, instead of original, I think I should have said we have our rate. And then we have, I'll put our original here. And then we have our new one. Okay, so let's say I'm converting 38 fluid ounces into pints. I go into my chart to find out what the rate is. So in this case, our rate, we're converting things from fluid ounces to pints, and the rate that we have is 1 pint is equal to 16 fluid ounces. So our new one, I have 38 fluid ounces, and I want to know how many pints I have. Once I've set up my little magic square, it's easy for me to create the ratio. So I'm going to have 16 over 1 is equal to 38 over x. We're going to cross multiply. So we have 16x is equal to 38. And then finally, we're going to take 38 divided by 16. So x is equal to 2.375 pints. Okay, sometimes we're given something like this. What's 8 pounds and, sorry, what's 8 pound 5 ounces in pounds? Well, the trouble is we have half of it already in pounds, but we need to convert 5 ounces into pounds as well. So I'm going to create a ratio as well where we have our rate, and then we have our ounce and weight. So according to our chart, 1 pound is equal to 16 ounces. I want to know what 5 ounces is in pounds. So I'm going to set up my ratio once again. And I have 16 over 1 equals 5 over m. Cross multiply, 16m is equal to 5. M is equal to 5 over 16. And 5 over 16 is 0.3125. Right, we have 8 pounds already. So 8 pounds, 5 ounces is equal to 8.3125 pounds. Now, if we're doing imperial to metric conversion, we're going to be doing the same thing. We need to convert something like 185 centimeters into feet and inches. Now, feet and inches are not the same unit. So we're going to do the same that we did when we came to pounds and ounces. Once we have the feet, all the decimal spots we're going to have to convert into inches. Great, let's first do this. We're going to go from centimeters to feet. Now, do we have the conversion we have here is 1 foot is equal to 0.348 meters. So let's make this into meters. 1.85. I've moved my decimal spot 2 steps over. And I have 1.85 meters. Okay, let's come back here and create our ratio. So feet and meters 0.3048 is 1 foot. And then our new one, I have 1.85, and I want to know how much this is in feet. Let's set up the ratio. 1 over 0.3048 equals x over 1.85. Let's cross multiply. 1.85 divided by 0.3048 is equal to x. Now I shortened it because I knew that if I multiplied this over, I'd have to divide it again. So I just left it like that. So 1.85 divided by 0.3048, 6.069 feet. Now, because we don't talk about point something of a feet, I need to convert 0.069 into inches. Right, so our chart, we're going to go back to the previous one. It shows us that 1 foot is equal to 12 inches. I'm going to create my foot over inches. So I have 1 foot is 12 inches. Now I want to know how many feet for 0.069. 0.069 divided by 12 is equal to F. F is 0.069 divided by 12. So it's not even 1 inch. Pretty much we are just at 6 feet. Okay, so we could say that 1 meter and 85 centimeters is just about a little over 6 feet. Now I showed you this, and this is the long way to do it because technology is able to do all of this for you very quickly. When I first started teaching, I would make sure everybody knew how to do it because the internet was not handy. But now I would say a majority of people have smartphones and the majority of people have data. So you could be anywhere and be converting. So let's go to Google. And if you go to Google, you can just type in the conversion. So 185 centimeters in feet and inches. And it'll do it for you. Okay, we got the same answer that we did, 6 feet, and then there's this. Now I'm going to convert this to get the centimeters as well. So the inch. Oops. Yeah, this is feet in inches. Oh, okay, so almost 1 inch. It seems like here we kind of messed up on our division. Let me check, how did we? One foot is 12 inches. Ah, I put it on the wrong side. Okay, 0.069, and this is inches, so I'll use F here. Okay. We can do, I'm not going to be pushing to talk about these because you can convert them. Now, what I will say is it's really important to know what units you're in because sometimes your diagram may come in 2 different units. All right, I'm going to give you a moment here. I want you to sort these cards. We're going to talk about capacity, weight, length, and we're going to compare this imperial and metric. So just match up the ones that are for each category. Great, let's take these questions up. First of all, in our slide, we have different categories. So length, we're talking about distance. Capacity, we're talking about volume. And weight, we're talking about mass. Hey, mile is an imperial length. Yard is also an imperial length. Pint is measuring volume. Meters is metric. Metric ton, this is weight. So this is the funny thing because there's actually 2 tons. One that is with a double N and an E, one without that. One is 1,000 kilograms and the other one is 2,000 pounds. So a bit of a pain, but those are our 2. Metric capacity, we have liters. Gallon is imperial. Quart is also imperial. Foot is imperial length. Then we have volts, hertz, bytes, and gram is weight. Now, one thing that you'll notice in the metric system really only has 1 unit for each one. Because when we're talking about meters and we want to make it a larger distance, we can add prefixes to it like kilometers. And if we want to make it smaller, we add prefixes like centimeters and millimeters in front of it. On the other hand, the imperial system, we have a name for different units that are bigger and smaller. Okay, slide number 6. I asked you to try this on your own. I wanted you to find out what these were, and I trust that Google is a good friend to you. So I'll give you another few minutes just to finish this up. Once again, if you have one of these compound measurement units, you'll have to convert both of them into the unit and then add it up. Let's take up slide number 6. How many gallons are there in 6 pints? We have 0.75 gallons. 12,500 pounds in tons. So this is interesting. What did Google say? Because we have a number of different answers from students. 12,500 pounds to tons. Now there's asking tons with the NES. So we're going to type it in the same way, 0.66. Let's round it to 0.67. 5.67. So 5.67 tons. 5 feet, 10 inches. This is a compound one. You're going to convert the feet and then the inches. So 177.8 centimeters. What is 8 pounds, 5 ounces? we're going to first convert 8 pounds. So if 8 pounds is 3.629 kilograms, and 5 ounces is equal to 0.142. So we're going to add those together. And we get the sum of it, 3.71 kilograms. Okay, so slide number 7, we're going to review our Pythagorean relation. I know this is something that you've done, so I'm just going to do a very quick review. Pythagorean relation states that if I have 2 sides, then I'm able to find the third side using Pythagorean relation. So I'm just going to write the definition. Okay, in a right angle triangle, if you have 2 sides, you can use a squared plus b squared is equal to c squared. To find the third side. Now, just a quick note is that A and B are always sides that touch the 90-degree angle. Now, in this question, we have right-angled triangle with a 5, a 7, or sorry, a 5, 9, and a C. You'll notice that if I were to use the equation, I would actually be calling this side A, this is B, and this is C. Because we said that side A and B are just sides that are touching the 90-degree angle. So now we need to find side C. We have A, well, our A is actually a C. So I have C squared plus 5 squared is equal to 9 squared. C squared is equal to 81 minus 25. And I have C is equal to the square root of 81 minus 25. So square root of 56. C is equal to 7.5. This is rounded. Now, I purposely gave an example where C is in the position of A. The equation A and B, these are just markers. It could have said x squared plus y squared is equal to z squared. But the main idea is that the 2 sides that are touching the 90-degree angle, if I square it, then it's going to equal the square of the hypotenuse. And the hypotenuse is the side that's across from the 90-degree angle. When you've taken this note down, please try slide number 8. Okay, let's take up this. Now, the first question is a bit tricky because the A, or what's labeled A, is actually the C, or the hypotenuse. So even though it's given that name, we can still express it as A, but we have to put it in the position of the C. So I have 10 squared plus 6 squared is equal to C squared. On the left side, I have 100 plus 36 is equal to C squared. Now, for me to undo the C squared, I now have to take the square root of the other side. So square root of 136 is equal to C, and C is equal to a rounded answer of 11.7. Okay, so I'm going to talk a bit about rounding here because some people I noticed wrote 11.6 as their final answer. If you're going to round to one decimal spot, we need to look at the decimal spot after it. And if the number is greater than 5, then the number is rounded up. If the number is 4 or less, then we just leave it the way it is. So this one would be rounded to 11.7 meters. Okay, next one, find the side length of R. R is the side touching the 90-degree angle. So we're going to put that as an A or a B. So I have R squared is equal to 7 squared equals to 12 squared. R squared plus 49 equals 144. R squared equals 144 minus 49. And we have R is equal to the square root of 95. Oops. So square root of 95, 9.7. Last one. This is another one that's tricky. We see that C is the one that's touching the 90 degrees. So this is really not a hypotenuse. Let's consider that as an A. So we have C squared plus 8 squared is equal to 13 squared. Simplify it, we have C squared plus 64 is equal to 169. Let's rearrange this equation. C squared equals 169 minus 64. C is equal to the square root of 105. So we get a calculated side of 10.2 meters. Daniel, if you would like to leave it as a square root, that's fine as well. Okay, so that's just another quick reminder of things that we've done in geometry before. Now we're going to do another review of geometry. Perimeter is the distance around the side. Okay, so I'm going to make it a little more specific. What's the perimeter? The perimeter is the distance around the 2D object. So I'm highlighting this. If I calculate the distance around there, we've got the perimeter. The unit is one-dimensional, or two-dimensional. So we use something like meters or miles or yards, but you'll notice that there are no exponents. Actually, I'm not going to say that it's on the other hand, we have area. Area is the space inside a 2D object. So here's our 2D object. The space inside, this is area. So the units that we use something like meters squared. We could say square yards. We could have kilometers squared. But note that the exponent is always 2. The way we say exponent 2 is square. So here we say meters squared, or when we're not expressing it with the 2, we could say square yard or square meter, square feet. Okay, let's very quickly talk about our 3 basic geometric shapes. We have our circle. Okay, so this is funny. Let's use this. A circle, you pull up the little toolbar on the bottom and you're able to draw a circle. So second one we're going to do is a triangle. So click on the polygon button. And when you hit the polygon button, you create your points. Click your last point again if you want it to finish. Okay, and the third one that we have is a rectangle or a square. So when we have a rectangle, that includes a square. A square is a special case of the rectangle in that all of the sides are the same. In the next slide, we're going to talk about the equation for perimeter and area. So remember, perimeter is the distance around our object. So if I have a length and a width here, my perimeter would be just adding up all of the sides. I have 2 lengths and 2 widths. So I could say that the perimeter is equal to W plus W plus L plus L. Now I can simplify that to P is equal to 2W plus 2L. Area is the space inside of our object. So I'm going to multiply my 2 sides together, length times width. Okay, perimeter for a triangle. I'm going to do the same thing. I'm going to label each of the sides, but this time, because I don't know whether the sides are equal or not, I'm just going to label them S1, S2, and S3. All that means is I've got 3 different sides and my perimeter is equal to each of the sides added together. Now you'll notice that a triangle is kind of similar to a rectangle in that if I were to extend it so that I have two sides that gave me another triangle, you'll notice that this is actually a rectangle. I've just added a second half to this. Now remember, the area of a rectangle is length times width. Now instead, what we're going to do is we're going to take length times width, but I'm going to divide it in half. Instead of length times width, we call this the base, and we're going to multiply it with the height. And we need to divide it by 2. Okay, so area in this case is half times the base times the height. Now, one note is that the height is a perpendicular. Height is perpendicular to the base. So for example, if I have a triangle like this, I actually have to create a height that goes straight through, because I need something that gives me a 90-degree angle. So that's my new height. The base would be S3, and I have this as my height. Now in a triangle like this, you could use, let's say you were using this as your base. Then we need to have a height that is perpendicular again. So just remember, the height always has to be perpendicular to the base. And then I just added a little note here. The equation is half base times height, because if we drew the other side to it, we would actually get a rectangle, and we just want half of it. Okay, let's take a look at slide number 12. We have a figure here. Find the perimeter of this figure. Okay, perimeter would mean I'm adding up all of the sides. There are 2 sides that I don't know. So I don't know what the value of this side is, and I also don't know the value of this side. But I'm able to use Pythagorean relation to help me find the value. I'm going to extend my rectangle, and I'm going to use the clues that are given to help me find the sides. Now, one thing I do know is that this is 6 centimeters. That means that down here, we're also going to have 6 centimeters. This height, I don't know what it is, but I know that the entire height is 20, as indicated in the middle. So I'm going to take 20 centimeters and minus 10, because that would be our difference. So this would give me 10 centimeters. I'm going to use Pythagorean relation to find this side. I'll label that side X. So 6 squared plus 10 squared is equal to X squared. I think this was a question that you did on slide 8, where you were asked to try this. So we have 36 plus 100 is equal to X squared. And we have x is equal to the square root of 136. X is equal to 11.7. Let me just check that. Okay, the second half, let's label this. I'm going to label this side y. I can say I know that the top part is 5 centimeters. And using the clues here, I know that the distance here is 8 centimeters. I got that by taking the difference of 20 and 12. So we have 5 squared plus 8 squared is equal to y squared. 25 plus 64 is equal to y squared. Y is equal to the square root of 89. So we'll solve it. We have y is equal to 9.4. Okay, now we're going to get our perimeter. We're going to add up all of the sides. So P is equal to 6 plus 10 plus 11.7 plus 5 plus 12 plus 9.4. So in total, we have P is equal to 54.1 centimeters. Right, slide number 13. The other basic shape that we didn't talk about is a circle. A circle is a bit different because when we're talking about a circle, we have to talk about the radius and the diameter. So the radius is the distance from the center to the edge. No matter what part of the edge you go to, if you're starting from the center going to the edge, they will all be exactly the same length. The diameter is the distance from one edge to the other, and it has to pass through the center. The circumference is a fancy way to say the perimeter of a circle. So if I'm ever saying find the circumference, it means find the distance around the outside. Now, using equations, we have circumference is equal to pi times d. So if you're typing in Desmos and you want the symbol pi, if you're in the math type, you can just type pi and you would get pi. Another equation, since we know that the diameter is equal to 2 radii, we could say that it is 2 pi r. the area being the space inside our shape, we're going to use the equation pi r squared. So generally the accepted one, we don't often say pi times 2r. You would say it as 2 pi r or 2d. And then for area, we would say pi r squared. So slide number 14, it is just a summary of the equations that we've talked about. Okay, if we're going to talk about composite shapes, the word composite means it's composed of more than one thing. Right, slide 15, we have separate these shapes into common shapes by adding or subtracting shapes. Meaning I want to cut this into parts so that I can have two shapes that I can manage, or more than two shapes. So let's say I have this upside down L. I can cut this shape into two different rectangles. An arrow can be cut into a rectangle and a triangle. This odd-looking shape, I can cut it up into a triangle, a rectangle, and a semicircle. Now, I don't know the equation of a semicircle, but if I know what the area of the entire circle is, then I can divide it by 2 to get a semicircle. Okay, this funny looking shape, we could cut it off here. So we've got 3 semicircles and a rectangle. A trapezoid, we could have 2 triangles and 1 rectangle. And this one, we could have, now there's different ways to divide it. You see this as 3D? So here I've got 3 rectangles and 2 triangles. Now you may have divided this differently. That is all possible. So let's do this example here. We need to find the perimeter and area of the composite shape. So composite, because we've got more than one shape, we're going to separate it and then we're going to add it all up. So for the perimeter, we're just looking for the outside. Oops, let's. So what I don't have is the semicircle. I do know that this side is 25 because this side is the same as this one, and this side is the same as this one, so I have 40. Okay, so perimeter. First, we're going to find the circumference of the semicircle. So circumference of the semicircle, we know that circumference is 2 pi r or pi d. In this case, I'll use pi d because I'm given the diameter, but I'm going to divide it by 2 because it's only half of a circle. Okay, so we have c is equal to pi times 14, all divided by 2. And we have c is equal to 7 times pi, 21.99. I'm going to round this because everything is to 1 decimal spot right now. 22 centimeters. Okay, so perimeter now, I'm going to add up all of my sides. 25 plus 40 plus 25 plus 40 plus 22. And we have 152 centimeters. Next, we're asked to find the area. The area in this case, we're just going to add our shapes together. So we have the area of the rectangle and then I'm going to add the triangle and the semicircle. So first I have the rectangle 40 times 25. Triangle, half times the base times the height. And then semicircle, I have pi r squared. R is 7 squared, and I have to divide the whole thing by 2. Let's throw this into the calculator. And we have A is equal to 1244.96. And we'll round it because we want 1 decimal spot. Oops. Okay, centimeter cubed or centimeter squared. Rounded to 1245 centimeters squared. Great, I'm going to give you some time now to work on practice questions 17 to 20, slides number 17 to 23. You're just asked to find the perimeter or the area of the composite shapes. Now see how much you can get done today, and if you're not finished by today, I will be giving some time at the beginning of tomorrow's class to work on it.